Good afternoon, everyone. Welcome to another session. This is session 5AQ, presented by Steve Warren. It's the second part of the zOS container extensions that Steve presented yesterday. So yesterday was part one, and this is its continuation. Steve has prepared a few slides, and he will try to do a live demo as well. Any questions, please raise them in the chat box, and Steve will try to answer them as he goes along with his presentation. So with no further ado, Steve, it's all yours.
Thank you, Uri. Good afternoon, everybody. Welcome to the zOS container extensions part 2 of 3 parts. So yesterday we gave a little bit of an introduction into what zCX actually is. Today we're going to do a quick recap of what we talked about yesterday. And then we're going to be focused on, okay, I'm interested in actually starting zCX at my shop. What things do I need to do in order to prepare to start that? We're going to talk a little bit about that, and then we'll focus on a bunch of other stuff. You'll see in the agenda in just a moment. But let me just tell you a little bit about myself in case you never seen me here. I work over across the pond in the States, in Poughkeepsie, New York. And for most of my career, I was in IBM zOS development. And then just recently, I moved over into another role as an architect, helping clients adopt new technologies. And so I've done quite a lot of work with zOS container extensions. And so I'm really looking forward to talking with you about this very exciting technology. And we're going to try some cool things. By the way, my email is here. Any questions that you don't get answered today, just please send me an email. And I'd be happy to reply to you. We've already had a number of folks that have taken me up on that offer, and that's great. We're happy to do questions. You can also, of course, raise questions in the chat, and we'll try to get to them as they come, okay? So what we're going to do today is we're going to talk about installation and prereqs of zCX after we just give a quick recap. Then we'll then talk about what things you need to have prepared for before you actually provision a zCX server. And so we're going to talk a little bit about, like, in terms of memory, CPU, DASD, networking stuff that's going to be necessary. And then I want to do a live provisioning workflow. Whenever you do a live demo, of course, there's always a risk that something goes wrong. You know, it's a Murphy's Law per se. But we're going to try it. And what I'd like to do is not only try it live, this is not a recording of a demo, it's an actual demo. So you can see on the wall clock how long approximately it takes on a very small footprint LPAR to provision a zCX. And as we have time afterwards, if we don't get to the last 2 bullets, that's perfectly fine. You can download that PDF file, and you can have the information. If we have extra time, we will quickly go through some of the key points on some of those slides, but again, not absolutely necessary. Okay, and so that's kind of where we're going to go today. And welcome to this session. Hopefully, you get some valuable information from it. Okay. So first of all, just as a recap from part 1, is zCX container extensions is a function that allows Linux on Z binaries that are packaged as Docker containers to actually be deployed and run directly on zOS. And the question is, what is the primary use case for that? Well, the primary use case is when your Linux applications need to interact with zOS applications, or to get get at zOS data, for example. So you don't need to provision a separate Linux server when you deploy zCX. Instead, you actually run your Linux application within an address space, and it's very cool. That Linux application doesn't even know it's running on zOS, or for that matter, it might even know it's running on Z at all. And so this is really great. When I deploy my Linux application, I don't need to provision a Linux server owned by some other group. in my enterprise. I can have it directly on zOS. And the big benefit is the co-location. My zOS application and my Linux application now are on the exact same LPAR. And when you have that, you're able to have this high-speed cross-memory network known as same host technology to be able to have pretty much the lowest latency possible between two applications in communication. And this is going to greatly improve your transaction throughput rates. And that's one of the key benefits of zCX. Another key benefit is that the operational control of those Linux workloads that interact with zOS can be controlled by your zOS guys. So now I can do a planned outage, and I don't need to coordinate with some other non-zOS admin, right? I can coordinate with myself because that Linux workload can also move somewhere else when I'm moving the zOS workload, for example. And as a side benefit, I'm also getting all these zOS qualities of service that are applying to Linux workloads transparently. Like we said before, the Linux application doesn't even know it's running on zOS, and yet the underlying technology that backs that Linux application uses the state-of-the-art zOS qualities of service. And so you're getting those also. And then we talked about that of course, this runs on 2.4 or higher, and that you need to run on an IBM Z14 GA2 or later, and to enable that. We'll talk about that technology in just a couple of moments about some of the requirements that are needed in the next section. Okay, so that's kind of an overview of some of that technology. There's a question about where do we download the slides? Rui, is there a way that they can get the slides? I think you can download the PDF pretty easily. I know some folks have downloaded it.
Yeah, I'll provide the instructions later.
Okay, great. Okay, thanks for your question, Juan. We'll hopefully get those slides to you. Okay, so the last introduction slide is one we had also from the first slide deck. And again, zCX is known as a turnkey virtual Docker server software appliance. It's a tongue twister and a lot of words there. What that means is that IBM pre-packages this appliance code. And so we have all the things you need to run Docker already pre-packaged and provided by IBM. You don't need to procure a Linux kernel or a Docker engine or any of the other utilities and functionality inside of the zCX. The only thing you need to deploy is your individual applications, because the Docker environment is ready to be utilized once we have your zCX provisioned. And again, we're using the high-speed network. We're backing the Linux disks for these appliances using standard vSAM linear data sets. And again, you have a Docker command line interface or a graphical user interface such as Portainer that can easily access your zCX appliance that you provisioned. And I can have one of these address spaces, or I can have multiple of these address spaces on the system. The key thing is for any of them, they're treated as unique started tasks. You can manage them using standard zOS operational procedures. And the best news of all is that up to 98%, or even, I would say even more than 98% in certain circumstances of the workload, it can be dispatched onto zip engines, making your monthly service, monthly licensing charges as close to zero as possible. So this is in a nutshell of what zCX is all about, okay? So with that, we're now going to go into the installation requirements. That was just a really fast 5-minute overview of the technology. And now let's focus on what you need to install zCX. So the first thing we need to understand is how zCX is structured. zCX parts of the code ship in one FMID and some ship in another FMID. So let's start from the bottom here. The zOS Linux virtualization layer is actually shipped as part of the zOS BCP. So in zOS 2.4, the FMID is the standard HBB 77 Charlie 0, which is actually the FMID of the zOS MVS BCP itself. Okay, so part of it, the part that does the 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 virtual IO devices and translating those into vSAN and TCP/IP, for example, that part is actually shipped within the base. What does that mean? When I actually get maintenance for zCX, I can actually get maintenance that is applied just to the BCP if the maintenance was just for the virtualization layer. More often than not, though, most of the code that is used to deploy zCX, and where a lot of times when you're going to be applying additional functionality as we have a continuous delivery of new functions that are added all the time, is going to be to the new FMID that was created in zOS 2.4, which is called HZD Charlie 7 Charlie 0, which includes both the Linux kernel and Docker engine, as well as the zOSMF workflows that you're going to need to run zCX. So the zCX appliance code is going to be deployed into a zCX address space when you are actually provisioning your zCX. And so as opposed to the virtualization layer, that code is not deployed inside of the zCX address spaces that you may create as a result of provisioning, but instead it's just part of the BCP that can be utilized. Okay, let's talk a little bit about dependencies too. So we already touched on this a little bit, but let's touch about it in a little more detail. The first thing is that I need to be at 2.4 or higher. If you're running on 2.3, zCX is not rolled back. So you're going to need to be at least 2.4 or 2.5, okay? The next thing you're going to need to know is that you need to be running on the right level of hardware. So the Z14 GA2, at least at driver 36 level, or a Z15, or whenever there are future hardware releases of zOS, those are that is the levels of hardware that you're going to need to be running. Now, if you have the right level of the operating system and you have the right hardware, now I need to have some what I refer to as enablement dependencies. And zCX needs to be enabled through one of three mechanisms, either by a hardware feature code, which is called the Container Hosting Foundation, by IBM Container Hosting Foundation for zOS, that is a monthly license charge, and then the zCX trial. That's a try and buy capability that you don't have to pay anything to try it for up to 90 days. Let's dive into what those enablement dependencies are in a little more detail. So a relatively recent addition for enablement is this thing called the IBM Container Hosting Foundation for zOS. And this is a zCX only solution. The hardware feature code that we talked about on the previous slide is applicable to potentially other things, other components of zOS may require that. So you may have already had that hardware feature code. If you did, you're all set. You don't need to do anything else. You paid the one-time charge for your CPC, and you have unlimited LPARs that can have unlimited instances of zCX running on that CPC if the hardware feature code is installed. Or you can choose the IBM Container Hosting Foundation for zOS. If you do that, you will incur a monthly license charge. You'll install that, and when you install that, it applies the same way. All the LPARs within that particular CPC are eligible to run zCX. Okay, so again, we have a flexible alternative. We have the hardware feature code 0104. You pay the price up front. You have the Container Hosting Foundation for zOS that has a monthly licensing charge. And of course, at T02, that licensing charge is reduced. And so, it's really your option. But you're going to have the same coverage with either one of these. It applies to all the LPARs that are running within that particular CPC. And again, you can have the 90-day trial option that allows you to try and buy before you actually enable that functionality. Okay, so again, a lot of clients have started with the 90-day trial, and then they've moved into one of the paid enablement options at a future point in time. So if you want the container hosting foundation for zOS, these are the list of things you need to do. I'm not going to talk about these in any detail. You should just be aware of, there's some steps that you have to follow, of course, in order to install that on zOS. All right. Now let's talk about what we need to plan for when we are going to enable zCX. And when before we're about to provision a zCX instance, we have to plan and think this out a little bit. There's going to be lots of questions that the zOSMF workflow for provisioning is going to ask you, and you need to be prepared to answer those questions. So let's just talk a little bit about the overall structures of zCX. So first of all, we have the idea of memory management. So the idea with memory management is that for zCX, you're going to assign a certain amount of memory to zCX for each zCX server or zCX appliance that you wish to bring up. For each one of those appliances, it's going to have that memory requirement, and that memory is going to be fixed above the bar memory. What does that mean? That means that whatever memory that you specify for this appliance is going to be off the table for any other zOS appliance to utilize, or any other zOS address space at all to utilize. Okay, because when you page fix something, of course, that storage is no longer available to something. It's dedicated to that particular address space. So in this case, this is what's happening. So you just need to be aware of that we're going to be sizing that correctly. We'll talk about that more in a moment. CPU management, again, we're going to have a virtual CPUs that are for each Docker instances. And what that translates into is MVS TCBs. So MVS tasks, you can think of it in terms of that. How many of these dispatchable threads do I want for a particular zCX instance? And of course, this is going to wildly depend on the workload you're running, what applications you're running, and how many applications are you running inside of that particular appliance. The next thing, of course, we have to be aware of is that we need to have workload manager policy definitions so that we can assign the proper priorities and or potentially cap resources for the zCX. And so we're going to have to think about that. And of course, we have normal SMF data that's available to enable our performance management and capacity planning. So those are just some overall concerns. Let's dive into each one of these topics individually and first talk about the fact that you can also remember that for each zCX server that you have an appliance for, you need to have some of these resources available. So in other words, you're going to have dedicated memory for each zCX instance. And I might want to have more than one in this case if I want to isolate applications, if I have different priorities for different types of applications, or I want to just cap particular resources. And so these are considerations. Do I want just one zCX server? Do I want multiple zCX servers? And again, each zCX address space is going to have its own disk space, its own network, and its own memory resources. They are, of course, going to share CPU resources with other address spaces. But of course, if I have a workload manager have a much higher priority for one server more than the other, the odds of the one server getting more CPU power is much greater, right? So this is just some things to consider when you're talking about zCX. I need to consider that I'm going to be having these dedicated storage, network, and memory resources. I am going to have shared CPU resources. Workload manager is going to influence that, and the idea of, do I need more than one? Okay, let's talk about CPU in particular. So I'm going to specify these number of CPUs for each instance. And the number of CPUs that I'm going to specify at provisioning time is going to translate again into the number of threads in that particular zCX. And the dispatcher are going to dispatch those tasks on whatever available zips. If you have honor priority enabled for your workload manager, which we'll talk about in just a moment, it could also dispatch it onto general purpose CPUs. The recommendation here is that you're not going to specify more virtual CPUs than the number of zip threads that you have available. Now that I noticed I didn't say number of zips, I said the number of zip threads. If you have SMT2 enabled, for example, for your zip engines, you have in theory more zip threads than you actually have zips. So the idea is though, that if I specify a significantly more number of virtual CPUs than I have the number of zips, I'm not really being very efficient with this appliance, because just like any other zOS address space, if I have lots of MVS TCB tasks that are running in parallel and I don't have any processors, or I have very limited processors to process all those tasks, I'm not really getting multi-threaded processing going on here. What's happening is one thread runs, then another thread runs, then another thread runs, because I only have, for example, one engine that has all these tasks that are trying to vie for that one engine. So again, if I really want true multi-threaded applications running in zCX, and I want multiple instances of them running, I need to make sure I have enough threads. And so again, virtual CPU is going to be important. It's going to depend on the applications that you have specified. You can change that value at a later point in time. You'll have to recycle the zCX appliance in order to modify and add more virtual CPUs in this example. To start off with, I think you need to have at least two, okay? That's a very minimal amount, but having at least two virtual CPs. So if you have two virtual CPs, if you had a couple of zip engines that are not utilized much on your system, that would be a good recommendation, you know, to start out with. Okay. Let's talk about memory. Oh, okay, so we have a question. Can you disable honor priority for the zCX WLM service class? Yes, you're going to lead into, just in a couple of moments, we're going to talk about the honor priority switch. And the answer to that in short is absolutely you can switch it. So it'll only run on zips if you are concerned about MLC costs and whatnot. If you just wait like maybe 2 or 3 slides, I'll talk more detail about that, Sean, okay? All right, let's talk a little bit about memory. So when we're talking about memory, again, we talked about this fixed private memory above the bar. And so for fixed private memory above the bar, I need to make sure that I right size this. So if the application needs to have a certain amount of gigabytes available, we need to make sure that we are not thrashing in the system with virtual memory going off to swap disk, etc. So we want to make sure that we have enough memory to run the application suites plus the zCX appliance itself. And so we say you should allow at least 1 gigabyte for zCX on top of what your memory estimates are. And again, we need to make sure that this memory is available in your system, and its use by zCX will not constrain your system. So we need to have the right amount of memory there. Okay. And avoid Linux swapping if possible. So we have a formula that's a 2-to-1 ratio when zCX images are using 8 gigabytes or higher. I'm going to show you an example of that 2-to-1 ratio on the next slide. And so again, we're going to try to tune this number to be most accurate. So here's an example. If I have 3 applications that are running in my zCX, and each one requires on average 5 gigabytes of virtual memory. So what I'm going to do is I'm going to use this formula that uses this 2-to-1 ratio. So 3 applications times 5 gigabytes plus 1 gigabyte for zCX itself gives me 16 gigabytes that I need for this appliance in total. But I don't necessarily need to provision the full 16 as memory there. I probably can have a combination of memory and swap disk space. So because 16 gigabyte is greater than that 8 gigabyte threshold that we said, anything greater than 8 gigabyte, we should use a 2-to-1 ratio. Well, because 16 is greater than 8, we're going to use that 2-to-1 ratio. And in this case, we're going to multiply 16 gigabytes times 0.66. That'll give us our 2 out of the 2-to-1 ratio. And that's 10.6. We're going to round up to 11 gigabytes. And so in this example, we would provision the appliance with 11 gigabytes, and we would create at least 5 gigabytes of swap disk space for us to deploy the zCX. So this is just an example of the capacity planning for memory that you might consider. Now, another thing to consider is how is this memory backed? All memory is backed by pages in virtual storage, correct? And so when we're talking about this backing of memory, we have 4K pages, 1 meg pages, and 2 gig pages that are all available as of the APAR that's listed on the bottom left of your screen. So now you're able to back these with much larger pages. And of course, the bigger the page, the less zOS overhead is going to be necessary to use those translation look-aside buffers. And so we found that you can get up to about 13% throughput improvements by using 2 gigabyte pages, up to 10 for 1 megabyte, and 4K, of course, you're not going to necessarily see any benefit. So again, the idea is you can choose the backing at the time when how you want to back the storage that you, or the memory that you have allocated for this appliance at the time you provision the zCX. You can change it if you need to at a later point in time. So again, 2 gigabyte pages are going to give you the best performance. Good flexibility is in the 1 meg fixed pages, because those 1 meg pages can be reused by 4K pages if they're needed. And again, you're going to use a combination of RSU and LF area parms in your IA SYS XX parm lib member to enable and to make more pages available for your system. Okay, so that's a very important consideration for memory. In terms of priorities of the system, again, now this is getting into that question about honor priority. So again, we recommend that you create a unique service class for your zCX applications. You can create multiple zCX ones. If you have different zCX appliances that you've started up and provisioned, and that they have different priorities, one has mission critical work, one has a little more on the discretionary side. So in this case, I might have a execution velocity goal for one of my service class to be higher than another execution velocity goal. Okay, and so that's one thing to consider in terms of the execution velocity goal differences between different appliances. I also may, for that mission critical work, I may say, you know what, I want to honor priority because I can't afford for this thing to take a long time. So if there are no zips available, I'm willing to spill over into GPPs. But for other workload, I may say, absolutely not. I don't want it to impact my MLC. I want to disable that. And so you can, just like any other service class in WLM, I can specify honor priority yes or no, and I can take default values that were set in a parm lib member in your IA opt XX parm lib member. Okay, so the bottom line is same flexibility as any other started task on zOS in terms of, do I want to honor priority or not? And again, you need to contact your WLM and capacity planners to determine what's the right value for you. And of course, you also have the ability to cap resources like you can with any other started task on your system. So you can associate the service classes associated with your zOS workloads with a particular group. And that group can set limits on, the amount of CPU consumption that you may have for that system. So again, you're going to consult your performance folks to determine what the best settings are for your environment. In terms of storage, we talked about that there is something called a VirtIO device, which translates the Linux kernel calls to Linux disk to vSAM linear dataset calls. And so, of course, we're able to leverage all the latest technology, whether it's pervasive encryption or replication technologies in Hyperswap, zHyperlink, and many more. All of those technologies are readily available to you using vSAM linear datasets transparently to your Linux applications. So what do those disks actually look like? Well, each zCX instance is going to require the set of VSAM datasets to be allocated for its exclusive use. If I create two zCX appliances, I'm going to have two sets of these volumes, of these disks that I need to have allocated. So when we provision our zCX, we're going to have to specify all the details of how these data sets are going to be allocated, because they're going to be allocated at the time we provision the zCX instance. We're also storing something in the ZFS file system. And we're going to store some important information about each of the appliances inside of a zCX file system that is unique. There's a zCX instance ZFS, and there's also going to be an overall ZFS, which is going to point to all of your remaining data sets. So just keep in mind. Now, the important point of this slide is to note the following. These are SMS managed data sets. So when you provision, you can specify a data class, a store class, and a management class to determine how these data sets are going to be allocated and where are they going to be allocated. Or you can use ACS routines to accomplish the same thing. The ACS routines, maybe based on the name of the data set, it's going to assign the appropriate class names for that. You're going to follow your standard installation practices to accomplish all of that. Okay, so on the next slide, we just give an overall view of how much DASD and what each of these disks, how much space they take. So if we just look very quickly, the most variable out of these are going to be the two that are in the middle, the user data disk and the swap data disk. Those can vary significantly. Let me just talk about those first. The user data disk is going to hold all your Docker images, the started containers, any logs that you have, and any Docker volumes that you have. Those numbers can vary pretty significantly depending on how many applications and what applications you have running. Some applications may be very huge. Some applications may store a lot of data. In that case, you're going to need to have a larger user data disk. Likewise, with swap data disks, based on that calculation we did just a little while ago, you may have a smaller or larger data disk. And so that smaller or larger data disk is going to, the swap data disk is going to depend on how much memory you need for your system. The other disks are going to be pretty much standard size for the most part. We recommend about 4 gigabytes for the root, the instance ZFS, and the alternate root. So the root is really the appliance itself, the code that runs, and the alternate root is basically when I actually provide an update to my zCX, it updates the alternate root, leaving the other system to be live. So even you can make updates to the configuration of your zCX appliance without affecting the live running of that. And then when you're ready to actually make the change, you just bring down the running zCX instance, and when you bring it up again, it will use the alternate root. So the bottom line is we're talking here at a minimum, you're going to need about 37 gigabytes worth of disk space in order to be able to deploy a single zCX instance. If I have 2 zCXs, I'm going to have at least 74 gigabytes worth of data, right? Okay. And now let's talk just about network integration. Then we're going to look at the live demo. So in terms of network integration, we have another VirtIO device that's in the zCX virtualization layer, which is actually allowing us to communicate with outside in TCP/IP outside our mainframe box, or to use the same host link to talk to other zOS address spaces in there. So we have to define something called a dynamic virtual IP address, or DVIPA. This DVIPA is not much different than a standard DVIPA that you may use for other middleware products like Kix, DB2, MQ, etc. This DVIPA gives you the ability to take down this server in the Sysplex and bring up this same server in another system in the Sysplex, provided you have all the necessary definitions defined on that other system. So dVIPA is a very powerful technology. And then there's this thing called the same host network that we're leveraging. And so we're going to have to make sure we configure for dVIPA and make sure we configure for same host so that our zCX can utilize these cool technologies. Also, if requests are coming in from the outside through your OSA Express card, you're going to want to enable something called inbound work queuing. If you already have it enabled on your shop, when you start up your zCX appliance, automatically zCX will enable this inbound work queuing. And the benefits of inbound work queuing are that, number one, my queue depths for my existing zOS address spaces inside of the OSA Express card are going to remain the same when I add zCX work, because zCX is going to have its own ancillary input queue. And so when the requests come into the OSA card, they're going to automatically go into a queue that's just as designated for zCX. In addition to that, when zOS TCP/IP grabs things off of that input queue, it actually can be dispatched on zips. So this is great. So even TCP/IP can be dispatched on zips if you're using inbound work queuing. So this is really a great thing and something that you should avail yourself of if at all possible. And of course, you can also define external network IP filters to restrict external access as well. Okay, so this is just showing the networking diagram. I'm going to go really fast through this because I really want to get to the demo. In this case, when you're communicating between zCX address spaces, or you're communicating between a zCX address space and an existing zOS address space, you're going to be leveraging this same host connection. Same host may already be enabled on your system, and if it is, you don't have to do any steps in order to enable that functionality. We'll talk just a moment about what that is. You will have to define unique dVIPA addresses for each zCX appliance you want to bring up. So if I have 2 zCX appliances, I'm going to need to have 2 dVIPA addresses defined. And again, for these applications to communicate, they're just going to use these same host links to communicate. And likewise, they're going to use the same host links when they're communicating between an existing address space and zCX as well. And then, of course, the external network is going to be using the OSA card. And again, IWQ comes into play for that. So I'm not going to talk very much about this slide. It has a lot of information here. The key points is that you need to specify zCX dVIPAs for each system, for each, zCX server that you want to deploy. And you need to make those definitions on all the systems that you may wish to move this zCX instance to. So if I just define it on one system and it comes up, that's great. But if I want, for example, for availability to bring down the zCX for a planned outage and bring up the zCX on another system, if I don't have the VIPA range statements defined over on that second system, that IP address is not going to be able to move over there, okay? And likewise here, all we're talking about with the same host technology, if you don't have it enabled already, and you might have it already if you already have dynamic XCF enabled, and if you don't have that defined, you must manually define IUT same H, which will create the necessary interface that zCX uses when communicating over the same host link. Okay. There's also OMP route profile updates that are possible. And if you have IP filters defined, you need to make sure that you permit routed and local traffic for those dVIPAs to enter into the zCX appliance. And this is an example of the VIPA range statement. You probably have quite a few of these for some of your middleware components. And in this case, the key differentiator here is that for zCX, you actually have to specify on this VIPA range statement the word zCX if you're doing it manually. If you're doing it through the zOS network configuration assistant for defining dVIPAs, then there's additional options that you need to specify to tell the network configuration system that this is a zCX dVIPA. And again, if you have SAF profiles that are protecting a particular dVIPAs, you're going to need to make sure that the zCX started task has authority to read those profiles so that it can actually have access to the DVIPA there. So again, you're going to need to make sure that you enable zCX to use those DVIPAs if you already have security in place. And again, we talked about IWQ already. I won't talk about that more. Here are some of the requirements for your own understanding. Last but not least, let's talk about user management. User management in zCX. How do we authenticate requests coming into a zCX instance? There's 3 techniques. There's local appliance registry. There's using zOS LDAP server with RACF integration, which means that you could use, for example, RACF credentials when you're coming into a zCX instance as the authentication mechanism. And finally, if you have an enterprise like Open LDAP solution, you can actually have the user authenticated through like Open LDAP or Active Directory. Now, we're going to be focusing on this example on the local appliance registry. And for me, I highly recommend that you start with the local appliance registry. That's going to be your best bet. It's going to be the easiest for you to be able to deploy zCX. And the local appliance registry is actually quite simple. What's going to happen is, and let me explain over here, is that you first are going to use some kind of an SSH keygen utility. It could be one that's provided on zOS. It could be one that's on PuTTY or on some other utility. The key is that you generate a public-private RSA key pair, okay? And when you do that, what's going to happen is when I provision my zCX, I'm going to be specifying the public key of that public-private key pair. And when I actually connect to zCX the very first time, I'm going to be specifying on the SSH command the private key that's going to allow me to get into that zCX appliance. And once I do that, I now can define my local appliance registry user IDs using sudo commands to actually allow for my Docker admins to have logins into my zOS, into my zCX appliance. At a later point in time, after you have this all set up, you have things defined, you can then dynamically, through a reconfigure workflow, actually enable either option 2 or 3 on the previous page to actually leverage either the Open Directory or the LDAP server with RACF integration. So you have several options here. The key is I would recommend starting out with just the local appliance registry for now. It'll get you started, and then at some point later on, if you have requests coming into your zCX appliance, you can then have it be authenticated through your security products that you have already there. Okay. All right, now it's time for a demo. And like I said, there's always a little nervousness that goes on when I give a live demo because there's always a possibility that something could go wrong. But I wanted to show you on the wall clock about how long it actually takes to deploy this. And so we have about just under 20 minutes to do this. So I think we can actually accomplish and do the demo here within a 20-minute period. So let's just see if we can do that. Okay. So what we have here is we have a zOSMF logon. Remember, we use zOSMF to actually provision my zCX. Hopefully everyone can see my zOSMF logon panel here on the screen. And what I'm going to do is I'm going to click on logon, and I'm actually going to be presented with the zOSMF desktop. And this is a workflow. So I'm actually going to click on workflows. And it's actually going to bring up my workflows that I've already currently loaded into zOS, into zOSMF that I've already run in the past before. And so you can see that I have a lot of workflows here. I probably should delete some because it takes a while longer to bring them all up in here. But in this case, I'm going to say actions, and I'm going to say I want to create a new workflow. I'm going to create a workflow here to actually provision a zCX appliance. So I'm going to provision it on this particular system. By the way, this is an extremely small footprint LPAR. And so this small footprint LPAR, you can see how long it takes on a very small LPAR to deploy. So you're going to, wherever you installed your zCX code and the workflows when you did the SMPE install of zOS is where you're going to be pointing to. So in this case, I've already done the workflow. So they actually are in the pull down here. And I'm going to say, I want to provision. I want to do the provision workflow. And I already have some user properties defined. The first time you define and run a workflow, you won't have user properties defined. But I want to pull the ones I already have defined so I can make my life easier. All the fields will already be filled in. So this just gives you an idea of how you proceed. So in other words, I'm going to be deploying this. The location of these files is on ZLP4. I'm actually going to do the workflow definition file is the provision.xml, and these are the saved files. When I click next, it's going to say, where is the workflow actually going to be performed? It's going to be on the same system in this case. And very important, I need to assign all the steps to the owner user ID. You're going to see that a lot of the steps in this workflow are automated. And if I don't specify this, it's going to make you manually go through each one of these steps. So we don't want to do that. Okay, so once I just click on the assign all steps to owner user ID, I can click on finish. And here is my workflow. So I have now the workflow, and there's many steps here. It looks a little intimidating. Believe me, the only thing you're going to have to fill in is step number 1. There's a lot of things to fill in for step number 1, but the rest of them are going to be automated. So there's a number of ways to actually kick off a step in a workflow. I'm just going to right click on this and say perform. When I do that, it's going to prompt me with all of the data that it needs to fill in. And whether it's the install directory, whether it's the name of the zCX appliance, I'm going to call it the job name of what I'm going to start when I'm done, and a bunch of other fields where I'm going to store the saved input parameters here that I'm entering in for the first time, and a whole bunch of other pieces of information here. And I'm not going to overwhelm you with all this detail. I'm just showing you some of the things you need to be aware of. So just general information. Here's where I fill in the number of virtual CPs. We said at least 2. I'm just going to say 1 here, but you certainly could say 2. We recommend at least 4 here. I'm just picking very small number, the absolute minimums that they allow. And then here's the page backing of how I want the pages that are related to this memory to be the page frame size. So in this case, I'm going to say first fit. If there's a 2 GB page available, use that. If there's a 1 megabyte page, use that. Otherwise, use 4K. If you want a consistent way of bringing up your appliance, some folks will just say for this particular option, use only 2 gig, for example. That will force zCX to be running at the highest level. And if 2 gig is not available, the appliance just won't come up. And when you try to start the appliance, okay. All right, the next thing is we're going to talk about a network configuration. So I can enter in a host name for this appliance instance, which I've already set up for a particular dVIPA address, and the guest IPv4 address here. I can also specify an IPv6 address if I want. If I had more than one TCP/IP stack name, I could specify which stack do I want zOS TCP/IP to be this appliance to be associated with. I can modify MTU sizes. I can specify DNS servers and a host DNS search option. Okay, I filled in all those fields. For instance directory, this is the zCX. For each zCX instance or each server that comes up, there is it has its own ZFS file system. And so for that file system, I want to know, okay, what is the primary size and secondary size? I would just take the default values of 4095 and 1000 here. This is the only one that has primary and secondary. The rest of them only have primary. This is very important, the group name. I want to specify a group name here that probably my zCX server is associated with through the started task, as well as any admins that may want to do lifecycle management on the zCX instance. I want to put them all in one group. The reason is because when I provision the zCX, the files in this ZFS file system are going to have an owner of the user that is currently deploying provisioning the zCX. But if you're in the zCX group, you're going to still be allowed to perform operations against this particular zCX appliance. Okay. Again, you can specify store class, data class, management class. And then we're going to go through these other things rather quickly. We're talking about the swap data configuration here. We had the root already defined. One of the key things to note here, I'm just going to go back to the root configuration here. When I did the root configuration, notice that because my root is over 4 gigabytes, I'm going to need to specify extended addressability. So I have a data class that actually has that attribute turned on. Of course, when you're addressing something over 4 gigabytes, you need to be aware of that. So I'm just going to go through all these things. This is just telling about what are the size of the data disks and where what data class and management class and storage class I'm going to be using. And so I'm going to take all these defaults. I'm going to go now to the Docker configuration. Now, the Docker configuration here is you might have to get some of this information from some of your Docker admins. What level of Docker logging do you want to have on? And what is the Docker logging driver? You can use either journald or JSON. And for either one of those, I can specify the exact logging options that they may wish to deploy. Like, for example, how large do I want my logs to be? How many days back, basically, do I want to go for that? I can also specify registries that allow me to, when I'm pulling packages from other sources, to be able to run Docker, to be able to obtain Docker images. I may have a secure Docker registry in-house that I might want to pull from. And so if you specify that information here, I can actually pull from, when I issue Docker commands from this appliance, it'll actually pull from those external locations. There's also proxy information that if you need that. And now this is very important in here as well. This is the Docker security information. So in this case, I'm going to specify a user ID, which is just unique for this particular zCX appliance. It doesn't have to be associated with any RACF or SAF user IDs that you've defined. And here's where, remember that SSL keygen that I said that generate a public private key pair? Here's where I'm going to cut and paste the public key. I'm going to place it in this particular file. And that way, the only person that's ever going to be able to SSH into this is someone that actually owns the private key. And then once you've established the user IDs, you don't need to worry about the public private key pair anymore. Okay. You can also, here's where you would enable LDAP authentication and where you would change from the current #1 level of security, local appliance registry security, to something else. Once I've done that, I say next. And if ILMT, I'm not even going to talk about that right now, just so we have time to just try to run this. I'm going to say finish. When I do that, it's going to kick off the actual workflow. Now, it doesn't actually start yet. I actually need to go to the next step and say perform, and it's going to say the following steps, this selected step, and actually all subsequent steps can be performed automated. So what I'm going to do is I'm going to take those defaults and say okay. And when I say okay, it's now going to be starting the process of provisioning. And again, this is real time on a very low machine. So you're going to see that we're going to have to, have some music running in the background here as we're waiting for these steps to do. Now, you notice there's 61 steps to actually do here. zCX employs something called parallel step execution, which allows this provisioning to happen faster. So it can actually do some steps that are not dependent on one another to actually run in parallel. And so a bunch of jobs right now are being run to configure the system. There's lots of days that are being allocated. There's lots of configuration files that are being set up. And so we can see what's going on. So if I hit refresh every once in a while, you'll see an update on the overall progress bar. And if you want, you can actually drill into any of these steps and see exactly where you are in the provisioning process. So we're moving along here. We're up to 23%. And you can see that, every time I click refresh, it's going to update this number, and we're going to have a certain number of things. I can tell you the largest step here is when they actually copy the code from your, wherever you installed the zCX binaries into your particular appliance. So when you copy the kernel and the Docker image and the other necessary items that make up a zCX appliance, That step is going to take by far the longest. Now we're up to 47%. You can see, imagine if you actually had a system that had actual resources, unlike my very small test LPAR, how fast this could run. So I'm just going to click refresh a couple times, and hopefully in just another minute or so, we're going to see it. And then we're actually going to start the zCX appliance. So we're up to 54% right now. And you can see from here where this is the step that takes the longest time, which is loading the appliance image disk onto vSAM dataset using the default job name. So that's what's happening right now. And so that one's gonna probably take about another 60 seconds or so. So we're gonna actually, while that's actually happening, I'm just gonna go back to my slide deck here, and we'll just look at a couple more slides, and then we'll come back and hopefully it'll be ready to go. So you can just see here, what just happened right there? Oh boy, I don't know what just happened there. Did I just foul up something here? I might have just fouled something up. Let's see. What did I do? This is what happens when you have a live demo, right? Let's see. Where did that provision just go? Okay, here it is. It's right here. Let me just go in here. Okay, I just refreshed the screen there. My bad here. I'm going to minimize this, and we're going to go in over to here. And just be another minute. I'll just get over a couple of slides here. So a key point while we're waiting for that to come up is that zOSMF has to be active on the system, of course, because we're using zOSMF workflows. Of course, everyone who is going to be provisioning and doing any lifecycle management on that needs to have the ability to use zOSMF workflows. So someone may be able to get into zOSMF, but do they have access to run workflows, right? You can look at this slide for additional details. There is an instance directory that needs to be created. This is the holding spot where whenever I provision a zCX, this is kind of like the anchor point of where all of the zCX appliances store a bunch of registration information. And so we recommend that you use the root global directory. And in this case, we used a zCX zOS as a subdirectory under global. Why do we recommend global? Because by default, global is shared amongst all members in the sysplex. So this will allow you to be able to start the zCX appliance on any system in the sysplex, provided besides putting this in the global directory that you have shared DASD for the other volumes that are stored, and you have the Viper range statement defined on all the systems in the sysplex. Okay, so this is another consideration. I'll just go one more slide. We'll take a look and see how we're progressing with that. Naming conventions, of course, you can specify high-level qualifiers, and we'll allow you to do that. So take some planning to discuss, your naming conventions and how you want to name the data sets that zCX is going to be creating. And then base security requirements. Of course, each zCX appliance is going to have a user ID associated with it. For RACF, that's accomplished through using the started class definitions. And of course, if you protect your high-level qualifier data sets for all those vSAM linear data sets that are created, you're going to need to make sure that the user ID associated with this zCX instance has at least control authority to all those data sets. All right, I'm going to go back and see if we actually have the thing fully provisioned. So let's go into here, and I'm going to refresh. And where are we? We're at 99%. Great. So we're on the very last step. So now if we look at this very last step, step 24, that is not automated. And it says right here that under the Perform tab that, okay, you're ready to start the appliance. And this is the syntax of how you could start the appliance. You could put this on the command line and it would actually start. I don't like to type all this stuff on the end, this conf line. And so I want to just type in my own unique proc. So what I did is I created a proc that has the job name and conf hard coded in it. And so now I'm going to go over to my system over here. And from the console, I'm just going to say start zCX INS 05. And when I do that, it's actually going to kick off the zCX appliance. I max down here. You can see that it's formatting the disks now the very first time. So this is really cool because it will only format the disk the very first time that you're provisioning. The first time right after you provision zCX, when you start it up, it has to format these disks. It's a one-time event. So if I go into DA here and I max down, I look at, I have other zCX instances. You notice I have started up here, but this is the one I just created. And I can actually get an idea of what's going on. It gives me some more information about what actually is happening. And you can see that it's starting Docker customization. And hopefully this will end in a minute. I can show you the very last step of this, which is actually logging on to the Docker appliance. And so we're just waiting for this to complete its initialization. So you can see that, it's sometimes you watch a video and they speed up everything and it makes it look like it's really fast. In actuality, this is not taking that long of a time. Now, you had to gather all those values for the zOSMF workflow so that you know what values to fill in for all of them. But assuming that you have those values, you've done your homework, you can do that. And now we're almost ready here to actually start. The appliance is almost completely up. And in fact, let's see. I'm hitting F8 like crazy here just to see the page down to see if it can finish up here. It's probably just another couple seconds here. What I'm going to do is I'm going to actually have the SSH where I know we're a minute past the hour, past the half hour here. I just want to get ready because I want to show you then how the proof of the fact that this thing is now started up. Okay, so it's still doing a little bit of cleanup. This is again, most of the time that we incurred here is because this is a one-time thing. So just bear with me. Okay, we're done. All right. When you see this message in the job log output for your particular appliance, it says, please connect to the CLI via your SSH client using port 8022, and the server is listening on 129.40, 110.70. That's the dVIPA that we use to provision this. So now if I just go over here, last step, I'm going to say SSH here from my SSH client. I'm just using PowerShell, but you could use any SSH client. I'm going to specify the private key that I have in my current directory here. So I don't have to specify any logon credentials here. And I'm just going to say admin. That was the ID we used when we provisioned it. And I'm going to specify the address that they said, 129.40.110.70. And I'm going to say port 8022 because that's what it said to do. Hit enter. And it says, welcome to zCX. So now if I do a Docker help command, for example, look, I have a normal Docker command line here. So this is proved that I now have my Docker engine here. I can now install Docker applications. I can now run Docker applications, and I'm going to have that same host connectivity of being right on the same system as my other Docker applications. So I'm just going to quickly go back to the presentation here, and we'll wrap up here. Okay, so you can look at these other slides at your leisure. I told you we probably wouldn't get through all of them. I wanted to give this just so you have an idea of the structure of the data sets that are there. And when you provision a zCX, how it works when you have multiple zCX instances. And then a little bit about lifecycle management and the input files that are created when you do a workflow. So again, you can review, if you want more information about zCX in general, introduction, you can look at the material that was given yesterday by me. And you can also come on Tuesday at 15:30, and we're going to talk about some practical use cases of zCX and see some use cases in action. Okay, so that's more information here at the GSE. There's some more information here. There's 2 excellent red books from zCX. I encourage you to check out these links. And I would also encourage you to avail yourself of a free workshop offering given by IBM. You can just simply send an email to myself or to the emails listed here, and we can walk you through. It's like about 12 hours of just hands-on there's hands-on experience. We're talking through exactly how you deploy it, all the stuff we talked about today in much more detail. And with that, I want to thank you for your time. I'm sorry we went a little over. Are there any other questions before we end today? ask you to also don't forget to fill out your evaluation to let us know what you thought about this particular session.
So guys, if you have any questions, please enter them in the chat box. Steve, another great session as always.
Thank you. It's fun. I mean, I wasn't actually in the development organization for zCX. I wasn't developing for many years, but for me, I was kind of like an end user, and I learned this stuff. And at first, it was a little intimidating. There's a lot of stuff to process and digest here. And that's why, one of the things when I joined as an architect, I wanted to come up with, something that could help other clients to get familiar with what they need to do in order to be successful with deploying zCX. And so, we're looking forward to continued interactions with you. But thank you very much for your time. Again, my email's on the cover. Feel free to avail of that at any time to ask any questions related to deployment of zCX.
Excellent, thank you. I don't think there are any other questions. So thanks everyone. Thanks, Steve. Just for FYI, the next session will be at 5 o'clock about eliminating dangerous installations exits. So I'll see you then. Thank you, guys. Thank you.
Okay, guys. Take care.
Cheers. Bye-bye.